Chapter 8. Is variation indefinite or limited? Wallace's Ternate essay was sent to Darwin in 1858 and titled, "On the Tendency of Varieties to Depart Indefinitely from the Original Type." It was published by the Linnean Society along with Darwin's own contributions. At the end of his essay, Wallace wrote, "We believe we have now shown that there is a tendency in nature to the continued progression of certain classes of varieties further and further from the original type, a progression to which there appears no reason to assign any definite limits." Wallace's title clarifies what evolutionists must show today: small, heritable changes that keep on accumulating. Making a similar case, Darwin accepted indefinite departure as true. In his 1844 essay, he argued that a limit to variation does exist in nature is assumed by most authors, but he was unable to discover a single fact on which this belief is grounded. But Darwin himself failed to provide a single fact to overturn what most authors had accepted. He would certainly have done so had he known of any. The birds his pigeon fancier friends bred always remained pigeons, and he was well aware of that. Neither Wallace nor Darwin ever observed indefinite departure, and both knew of the counterclaims against it. Nonetheless, most biologists and all Darwinians since then have regarded indefinite departure from the original type as a given, without so much as asking whether it has been demonstrated experimentally. So the question arises, has it ever been demonstrated? If not, there may be no scientific reason to accept Darwinism as a fact. Philosophical arguments in favor of an uninterrupted parent-offspring change since the origin of life may be quoted, but the key evidence would still be missing. It is usual at this point to make a distinction between microevolution and macroevolution, and to add that microevolution is obviously true. You differ from your parents, and you may do so in 1,000 ways. We all differ from each other in small ways. Therefore, the argument goes, microevolution is a fact. But it is misleading, surely, to identify small individual differences as evolutionary, even if only in a micro way. Variations between generations were known to us long before Darwin, without ever being regarded as small steps in the direction of something completely new, incipient speciation, for example. They are a fact of life, not evolution in miniature. Darwin, nonetheless, assumed that small changes do accumulate. It was central to his theory, virtually a restatement of it. It was based on extrapolation from the small variations that we see every day, and which animal breeders can, to a small extent, magnify. But was this extrapolation justified? A number of observations on this topic have been made over the years. A brief summary follows. First, consider Thomas Robert Malthus, 1766 to 1834. He died 25 years before The Origin of Species was written, but his famous Malthusian theory strongly influenced Darwin. Nonetheless, Malthus preemptively rejected indefinite departure. In the following, Malthus used the word improvement instead of evolution, a word that was still not in general use. In his essay on the principle of population, Malthus wrote, "One of the most obvious features of the improvement is the increase of size. The flower has grown gradually larger by cultivation. If the progress were really unlimited, it might be increased ad infinitum. But this is so gross an absurdity that we may be quite sure that among plants, as well as among animals, there is a limit to improvement, though we do not exactly know where it is." Francis Galton, 1822 to 1911, Darwin's half-cousin, they shared a common grandparent, was an early eugenicist and statistician. He published Regression Towards Mediocrity in Hereditary Stature in 1886. Characteristics, for example height, in parents are not passed on completely to their offspring, he wrote. Rather, features in the offspring tend to regress towards a mediocre point, since referred to as the mean. Tall people usually have tall children, but maybe not as tall as their parents. Height, in other words, approaches a limit. The very idea that there is what Galton identified as a mean fits uncomfortably with the idea of indefinite departure from the original type. At the least, it challenges the idea. In Chapter 1 of The Origin, Darwin brought up reversion to the mean. He referred to a statement often made by naturalists, namely that our domestic varieties, when run wild, gradually but certainly revert in character to their aboriginal stocks. Hence, it has been argued that no deductions can be drawn from domestic races to species in a state of nature. But Darwin had no time for such negative thoughts. He countered that in many cases we do not know what the aboriginal stock was, and so we could not tell whether or not nearly perfect reversion has occurred. But it isn't necessary to observe perfect reversion to demonstrate that characters enhanced by domestic breeding are quickly lost in the wild. Darwin wanted to believe that he had discovered a process comparable to a journey that could be extended indefinitely, not just one of a few steps which are then reversed. Reversion to the mean suggests the metaphor of going for a walk or going to work and then returning home, as opposed to wandering eternally. In fact, having no home epitomizes the Darwinian worldview. Furthermore, this wandering nature of evolution addresses a desire to escape tradition, stability, and home. It is progressive in the fullest sense of that word. To alter the metaphor, reversion to the mean implies that species inhabit plateaus of limited space upon which variants are free to roam. Artificial selection can push varieties to the edge of the plateau, but they cannot be pushed off it or be made to invade the terrain of adjacent species. No experiment has shown us otherwise. The Danish scientist Wilhelm Johansen, 1857 to 1927, was the first to introduce the term gene and to distinguish between genotype and phenotype, between the hereditary disposition of an organism and its bodily manifestation. In Darwin's Century, the author Loren Eiseley cited Johansen as explicitly denying indefinite departure. The variations emphasized by Darwin in species change, wrote Eiseley, cannot be selectively pushed beyond a certain point. Such variability does not contain the secret of indefinite departure. The Columbia University geneticist and Nobelist Thomas H. Morgan, 1866 to 1945, known for his experiments with fruit flies, spent a good deal of time investigating the Mendelian laws of inheritance. He also questioned the idea of indefinite departure. Selecting for extra bristles in fruit flies, he found that such selection at first produces rapid effects, which soon slow down and then cease. Like others who followed him, Morgan assumed that Darwinism could be saved by positing that the appropriate mutations appear in sequence. But such sequential mutations have not been observed. Later, when Herman J. Muller bombarded fruit flies with X-rays in an attempt to speed up the mutation rate, the fruit flies that survived the onslaught stubbornly remained fruit flies, although some had bizarre shapes that were not transmitted to offspring. Luther Burbank, 1849 to 1926, a resident of Santa Rosa, California, funded by Andrew Carnegie, was called the most competent breeder of all time. His standing as a scientist is questioned today because his record-keeping was supposedly hit or miss. He nonetheless formulated a law, the reversion to the average. It is difficult to find Burbank's books today, but the following passage was quoted by Norman Macbeth in his book Darwin Retried. I am willing to admit that it is hopeless to try to get a plum the size of a small pea, or one as big as a grapefruit. I have daisies on my farms little larger than my fingernail, and some that measure 6 inches across, but I have none as big as a sunflower and never expect to have. I have roses that bloom pretty steadily for 6 months in the year, but I have none that will bloom 12, and I will not have. In short, there are limits to the development possible, and these limits follow a law. Julian Huxley, the grandson of Darwin's bulldog, also found that breeders encounter limits. In spite of intensive and long-continued efforts, breeders have failed to give the world blue roses and black tulips, A bluish purple and a deep bronze in the tulip are the limits reached. True blue and jet black have proved impossible. Huxley attributed this limited variability to a lack of modificational plasticity, a polysyllabic restatement of the problem. Variation can only go so far. Different species of plants differ greatly in this respect, Huxley added. Some remain extremely constant in a wide range of environments. As for animals, we have less information on the subject. When Huxley wrote that, the centennial of Darwin's 1844 essay was approaching. In 1980, the science writer Roger Lewin described a gathering of about 150 leading evolutionary theorists at the University of Chicago. Their conference was entitled Macroevolution, and their task was to consider the mechanisms that underlie the origin of species. Lewin wrote the following in Science magazine. The central question of the Chicago Conference was whether the mechanisms underlying microevolution can be extrapolated to explain the phenomenon of macroevolution. At the risk of doing violence to the positions of some of the people at the meeting, the answer can be given as a clear no. The French zoologist Pierre-Paul Grasse, 1895 to 1985, spent a lot of time studying bacteria. A Lamarckian, Grasse remarked, "What is the use of their unceasing mutations if they do not change? In some, the mutations of bacteria and viruses are merely hereditary fluctuations around a median position, a swing to the right, a swing to the left, but no final evolutionary effect." In Darwinism, The Refutation of a Myth, 1987, the Swedish embryologist Søren Loftrup said something similar. He wrote, "Neither in nature nor under experimental conditions have any substantial effects ever been obtained through the systematic accumulation of micro-mutations." Richard Dawkins, in his book, The Greatest Show on Earth, 2009, restated the conventional Darwinian position. The idea that there are limits to variation is essentialist, he said, something that Plato would have embraced. Dawkins illustrated his argument by referring to rabbits, but he could have used any other animal. The Platonist regards any change in rabbits as a messy departure from the essential rabbit, and there will always be resistance to change, Dawkins wrote. The evolutionary view of life is radically opposite. Descendants can depart indefinitely from the ancestral form, and each departure becomes a potential ancestor to future variants. The idea of a standard rabbit denotes no more than the center of a bell-shaped distribution of real rabbits, and the distribution shifts with time. Dawkins then continued, "As generations go by, there may gradually come a point not clearly defined when the norm of what we call rabbits will have departed so far as to deserve a different name. There is no permanent rabbitness, no essence of rabbit hanging in the sky. What was once part of the old distribution may find itself the center of a new distribution later in geological time." All is fluid, Dawkins wrote, recalling Heraclitus. Nothing is fixed. After 100 million years, it may be hard to believe that the descendant animals ever had rabbits for ancestors. Dawkins gave no examples. What preceded the rabbit? He didn't say, because he didn't know. He treated Darwinism as an established fact and deduced indefinite departure from it. He reverse-engineered his own conclusion. When Darwinism is treated as a fact, as it is in Dawkins's books, indefinite departure must be true. To cap it off, he used ridicule, essence of rabbit hanging in the sky, to delegitimize the alternative. Jerry Coyne made a related case explicitly defending Darwinian extrapolation. When, after a Christmas visit, we watch Grandma leave on the train to Miami, we assume that the rest of her journey will be an extrapolation of that first quarter mile. A creationist unwilling to extrapolate from micro to macroevolution is as irrational as an observer who assumes that, after Grandma's train disappears around the bend, it is seized by divine forces and instantly transported to Florida. Like Dawkins, Coyne serves up his argument with a dose of sarcasm. Of course, the two cases are not remotely comparable. We know from thousands of observations and no counterexamples that trains have repeatedly traveled beyond that first quarter mile, all the way to Miami. On the other hand, extrapolating from micro to macro evolution asserts as true something that has not yet been observed. Vincent Torley, a philosopher, responded to Coyne's example as follows. It is really hard to know if Grandma will ever arrive at Miami when she is laying the track, randomly directed, one rail at a time, as she goes. When you rely on random variation and natural selection as Coyne does in his metaphor, the track that he presupposes isn't even known to exist beyond what has been observed. Coyne himself is pleased to tell us in another context that natural selection is non-directional. So even if many such tracks could be created, they might lead anywhere or nowhere. Note also the real significance of Coyne's far-fetched defense of extrapolation. If the real thing had been observed, so that evolution could be extrapolated, Coyne wouldn't have needed to reach his desired conclusion by extrapolation. In his rabbit example, Dawkins set forth the Platonic case for essentialism. We are told that it is misguided, even though it is all that we ever see. Its denial assumes that an antecedent organism is slowly transformed into a rabbit, which generations hence will become something else. Therefore, no essence of rabbit exists. But no known facts compel us to accept such a claim. It is simply a deduction from the theory of common ancestry that was central to Darwin's theory. John Stuart Mill, Darwin's well-known contemporary, was also opposed to the idea of essences in the non-biological realm. He wrote that there has always been a strong tendency to believe that whatever is given a name must be an entity, having an independent existence of its own. If no real entity answering to the name could be found, men did not, for that reason, suppose that none existed, but imagined that it was something particularly abstruse and mysterious. But it is precisely the Darwinians who live in Mill's abstruse and mysterious world. Theirs is one of common ancestors, theoretical beings that are never identified. Stephen Jay Gould once said that Darwinian trees of life identify organisms at tips and nodes. But the fact is that nodes are almost always left vacant because we don't know what organism should go there. The fact is, we continue to live in a world of essences, and yet, at the same time, we are expected to oppose essentialism. Denying the reality of essences became the lifelong campaign of Ernst Mayr, 1904 to 2005, as ardent a Darwinian as you'll find. He devoted decades of his long life to obsessive assaults on essentialism, hoping to replace it with what he called population thinking. He also said that, although he didn't realize it at the time, Darwin invented the concept of biopopulation. This is the idea that the living organisms in any assemblage are populations in which every individual is uniquely different. In a late interview, Mayr claimed that Darwin showed that essentialist typology was absolutely wrong. Darwin did no such thing, although it arguably was wrong if his theory had been shown to be factual. But like Richard Dawkins, Ernst Mayr derived his facts from his antecedent faith that evolution has been established. As so often in evolutionist thinking, deduction from doubtful premises is substituted for scientific observation. Elliot Sober, a well-known philosopher of science at the University of Wisconsin, addressed this topic in his 1980 article, Evolution, Population Thinking and Essentialism. He made an initial effort to defend essentialism. Chemistry, for example, is a field in which such thinking had been vindicated as the periodic table of elements showed. The essence of each kind is its atomic number, and it was hardly irrational for chemists to search for this feature. Their assumption that such essences were out there, far from stifling inquiry, was a principal contributor to that inquiry's bearing fruit. Therefore, essentialism in chemistry is a legitimate working hypothesis. But when he turned to biology, Sober's outlook was congenial to many of Mayer's views. The gradual evolution of species must mean that the boundaries of species are vague, he said. Yet, he added, essentialists hold that there are characteristics which all and only the members of a given species possess, so their views are not tenable. Sober, in short, could not bring himself to question Darwinism, and in his deference to the dominant evolutionist culture of our time, he aligned himself with Dawkins, Mayer, and others. The philosopher Marjorie Green later defended essences, even though she supported evolution broadly construed. Mayer's population thinking turns out to be ontologically impossible, she said. Types, kinds, and sorts are bound to crop up somewhere, for if they didn't, we not only could not speak about nature, there would not be a nature to speak about. Evolutionists impugn typology, she said, by saying that its advocates view types as eternal, whereas in reality the living world is constantly changing. To this, Green retorted, "I have always found this argument very difficult to understand. Why, just because something does not last forever, should it lack a nature? That animals are born and die doesn't mean you can't tell one from another while it lasts, or even after it is dead. Why equally shouldn't we be able to talk about the nature of a certain collection of plants or animals, or better yet, a family or lineage of plants or animals? There are no mammoths nowadays, but surely we can say something about the kind of ungulates mammoths were." One might put it this way: if there is no essence of human beings, why are we never in doubt as to whether the being that we see is human? We never have reason to say, "It's hard to say whether that organism is human or not." Nor do we live in a world in which we say, "Is that a cat or a dog?" Could be one or the other. Small children can instantly recognize the difference without any help from anatomists or systematists. On the other hand, we can encounter ambiguity when lions and tigers mate, as they sometimes do. Their offspring are not merely ambiguous, but usually also barren, like mules. Ernst Mayer's lengthy campaign against essences, also placed front and center by the textbook writer Douglas Futuyma, should be seen as a bid to disguise the shortcomings of Darwinism. As for unlimited variation or indefinite departure, it has not yet been observed. If it had been, we would never stop hearing about it. It has been deduced by assuming the truth of the theory that it is meant to confirm. The continued advocacy of indefinite departure by biology departments amounts to the triumph of ideology over science, or perhaps we might say, to the triumph of hope over experience. Perhaps then, the original type is something real that cannot be escaped. Ernst Mayr thought that essentialist typology was absolutely wrong, but maybe it is absolutely right? Earlier, in The Origin of Species, Darwin inveighed against archetypes. Maybe archetypes are real too. In biology, essence and archetype both convey the same idea. An archetype is commonly understood as a Platonic ideal, not a physical thing. We are told that we never see a real circle, for example, only a close approximation of one. It may be, then, that what we are seeing anatomically in succeeding generations is the repeated attempt to reproduce the archetype or essence of a given species. Darwin, on the other hand, expected to see, and his followers still expect to see, something quite different, a species or type that is constantly in the process of becoming something else. So the claims of Darwinism and essentialism are in direct conflict. The truth is that what we observe, year in, year out, decade after decade, is much closer to the latter than to the former.